Hello everyone, I am Rohan Jadoun. In this video, we will learn about compression, lossy compression techniques, image compression. So, firstly, compression. Uh, the compression is the process of reducing the volume of data by applying a compression technique. Is called compression. The process of coding that will effectively reduce the total number of the bits needed to represent certain information is also known as compression. The resulting data is called compression data. The solution is compression. We need to compress this data objective to reduce the file size. The compression ratio should be high. If it is less than 1, it is known as negative compression and it must be avoided. The unit to specify the amount of compression is compression ratio. It is given by where B0 total number of bits required to represent data before compression, B1 total number of bits required to represent data after compression. Now, the advantages of compression are uh, it helps in reduce file size, it helps to save disk space, it increase transfer speed at a given data rate, allow real-time transfer at given data rate. Here are some compression types: special compression, temporal compression, quality of compression. In special compression, it finds similarities in an image and compares those similarities in a smaller form. Second one is insta frame. Now, in temporal compression, it finds similarity across images and compresses through the similarities in a small form. Interframe. Third one is quality of compression, lossless and lossy. So, lossless compression. Lossless compression method may be categorized according to the types of data they are designed to compress. Three main targets for compression algorithms are text, image, sound. Any general purpose lossless algo can be used to compress, which can handle binary data and the type of data. But many are unable to achieve significant compression. For example, sound data cannot be compressed well with conventional text compression techniques. Lossless technique can be achieved reduction in size in the range of 1 to 10 to 1 to 50 of the original uncompressed size without visibility affecting image quality. The accepted lossless standards are packet bit encoding, run length encoding, CCITT group 3.1D, CCITT group 3.2D, CCITT group 4, Lampel-Ziv and Welch algorithm. Now, lossy compression techniques are lossy. This compression reduces the size of the file by permanently eliminating certain information, especially redundant information. When the file is uncompressed on the information would be there. Lossy compression is generally used for videos and sound, where a certain amount of the information loss will not be detected by most users. Here are some examples. When a video image is decompressed on a frame by frame basis, the loss of the data in a frame will not be perceived by the eye. A person might not notice if some of the finest details of the scenes are removed or are represented perfectly. Here are some lossy applications. The primary application of the lossy compression technologies is in the multimedia applications such as medical screening system, video teleconferencing, and multimedia messaging system. The JPG image file, commonly used for photographs and other complex still image on the web, is an image that has lossy compression. The accepted lossy standards are joints picture, expert group, moving picture, expert group, Intel DVI, CCITT H.261, PX64 video coding algorithm, fractals. Image compression, JPG compression. JPG is an image compression standard developed by a joint photographic experts group, firmly accepted as standard in 1992. It is a compression standard for still image and grayscale image.
The standard was released by ISO in two parts. Part 1, it specifies the model of the operations interchange formats and the encoder decoder specified for these modes along with the substantial implementation guideline. Step 2, it describes compliance test which determines whether the implementation of an encoder or decoder conforms to the standard specification of the part 1 to ensure inter interoperability of systems compliant with JPG standard. Now JPG compression. So this is the definition of JPG standard. The three levels of definition in the JPG standards are baseline system. It must reasonably decompress color image, maintain a high compression ratio, and handle from 4-bit per pixel to 16-bit per pixel. This level ensure cost-effective software implementation. Custom VLSI level ensure cost-effective software implementation, custom VLSI implementation, and DSP implementation of the JPEG standard. Second one is extended system. It covers various encoding aspects such as variable length encoding, progressive encoding in the and the hierarchical encoding. Special lossless function. It is also known as a predictive lossless encoding, the ensure lossless compression. JPG modes of operation. The four modes of operation or component of JPG are baseline sequential, codec sequential DCT based. Consists of three-step formation of DCT, coefficients, quantization, and entropy encoding. 18 to 8 blocks of image inputs are formatted for compression by scanning the image left to right and top to bottom. Block consists of 64 samples of one component that make up the image. Each block now transformed to the block of coefficient by the forward discrete concise transform. The coefficient are the quantized and the entropy encoded using Huffman coding. This is rich compression scheme sufficient for most applications. JPG modes of operation. Predictive lossless encodings, transmitting the difference between the next sample and the errors after equating the current sample. The difference is encoded lossless using Huffman or arithmetic entropy encoding. Second, hierarchical. It encodes the image and hierarchical of the several different resolution. It encoded image at the lowest resolution is basically compressed low pass filtered image. In this, each successive encoding of image is reduced by a factor of 2 in either the horizontal or vertical dimension. Hierarchical encoding needs more storage capacity, but high resolution image can be obtained. JPG compression quantization. It is the process that attempts to determine what information can be safely discarded without a significant loss in visual fidelity. The process of quantization reduces the number of the bits need to encode data and also to increase the number of zeros valued coefficient. For the purpose, each DCT coefficient is divided by its corresponding quantization value and is rounded to a nearest integer. Dequantization is performed by the multiplying each DCT coefficient by the corresponding quantization value. The dividend in the process is rounded. Thus, the technique is lossy as the decompression process cannot recover the original value of each pixel. Entropy encoder decoder. Entropy is a measure of disorder, randomness, as well as measure of a system ability to undergo spontaneous change. The entropy encoders compression quantized DCT coefficients more compactly based on their special characteristic. Here, JPG encoding. Steps involved a discrete concise transformation of the each 8 into 8 pixel array. Uh, Quantization using a table or using a constant. Zigzag scan to exploit redundancy. Differential pulse code modulation on the DC component and run length coding of the AC component, entropy coding of the final output. Thank you.